In this lecture, we are going to look at DynamoDB consistency model. We have read consistency and write consistency. In read consistency, we have three types: strong consistency, eventual consistency, and transactional consistency. And then we have write consistency, where we have standard consistency and transactional consistency. So what exactly are these consistencies? First, the strong consistency. So when you read a DynamoDB table using strong consistency, you are bound to get the most recent or most up-to-date data. And when you make the read request, you must explicitly mention that you want to use a strong consistency. Then we have eventual consistency. So this may or may not be the latest copy of data, and we'll see what I mean in just a bit. This is the default consistency for all read operations, and this is 50% cheaper than strong consistency. So DynamoDB charges you twice as much if you use strong consistency as compared to eventual consistency. And then we have transactional consistency that you can use for reads as well as writes, and this is something that helps you get ACID compliance with your transactions. Transactional consistency comes at twice the cost of your strong consistency reads, or twice the cost of your standard writes. All right. So let's understand how the strong and eventual consistency works. So we have an application here, and we have different DynamoDB servers. So as we have seen earlier, that DynamoDB replicates your data across at least 3 different facilities. So whenever you write something to DynamoDB table, it is written to one of the facilities and it is then replicated to the other 2 facilities. And whenever you request a read operation, the data will be returned from one of these facilities. So if you're using eventually consistent read, then data will be randomly returned from one of the facilities. So it's possible that you just wrote something to a facility, and if you read it from some other facility before that data was replicated, you might get a stale copy of that data, which may not be current. So this is how eventual consistency works. Then you have strong consistency. So if you ask DynamoDB to read some data with strong consistency, it will ensure that you always get the latest copy of the data. So if you write to a facility, DynamoDB most likely will return you a copy of the data from that same facility to ensure strongly consistent read. Now, as we have discussed, by default, DynamoDB uses eventually consistent reads, but if you set the consistent read parameter in your get item, query, or scan requests, or in other words, in your read requests, then you can get a strongly consistent read. And now let's look at the transactional consistency, or DynamoDB transactions. Now this is where DynamoDB provides you with ACID compliance. So if you want your DynamoDB table to be ACID compliant, then you can request transactional consistency. Transactional consistency allows you to write to multiple tables at once or not at all. So that's what we mean by transactional consistency. So for example, you have an account balance table here, and you have a bank transaction table here. So whenever there is a transaction in the bank transactions table, then account balance should get updated in the account balance table. So you can't have a transaction being written to bank transactions table without account balance being updated in the account balance table. That might result in inconsistency of the data. So transactional consistency ensures that the data is written to both these tables or none of them. So that is the meaning of transactional consistency.